this lesson is going to be on entropy. And entropy is related to the spontaneity of a reaction. And so you need to know if a reaction is going to go by itself or if you need to put in energy to make the reaction go. If a process occurs naturally all by itself, it is said to be spontaneous. So setting a nail outside, it rains, it rusts, that's a spontaneous reaction. So iron rusting, ball rolling down a hill, spontaneous processes. With entropy, that's going to be the change in the amount of disorder or randomness. So entropy, we're going to use the variable S, and that's going to measure how much disorder is in a system. If you increase your disorder, your delta S is going to be positive. And law of disorder states that processes are going to move in the direction of maximum disorder. So if you have a handful of marbles and you toss them in the air, the marbles are not going to fall neatly back into a pile. They're going to scatter. So things want to be disordered. So as far as entropy with your phases, solids are going to have the lowest entropy. They are the least disordered. Then liquids and then gases are going to have the highest entropy. They are the most disordered. So solid, all nice and lined up, very low entropy. Liquid is kind of still in an orderly fashion, but a little mixed up. And then here's our gas all over the place. So high entropy, low entropy. So entropy can increase when something is divided into parts. So if you take a puzzle and you break it apart, or when we crushed our Alka-Seltzer, we increased the entropy. It's going to increase when you have more moles of product versus your moles of reactant. So if your coefficients over here increased, you have increased the entropy. You have caused more disorder. It's gone from 2 nice, neat little water molecules to 2 hydrogens and an oxygen molecule. So you've increased the disorder. Entropy is also going to increase when temperature increases. So if you increase the heat, those molecules are going to start to move about a little bit faster, running into each other more. So you've increased the disorder, the chaos that's there. So you can see these molecules aren't moving very fast. They're just kind of hanging out, and then they start to move faster. And then here we've heated it up enough that you actually had to put a lid on it so that the gases couldn't escape. So you've increased the entropy by changing the state of matter. So we've gone from a solid to a liquid to a gas here.